Superposition theorem. This is one of those theorems you use in analyzing a circuit. Now, superposition theorem states that if there are more than one independent source in an electric circuit, that the response of the network, the response could be voltage or current, can be determined by considering one source at a time, and that the total response is the algebraic sum of the independent responses. So what is simply saying that in a circuit, if I have more than one source, maybe I have 2 or 3 sources, it could be a voltage source, it could be a current source, that in analyzing the circuit, we consider one source at a particular time. Now, note that if we are determining the response of one particular source, all other sources must be deactivated, and the voltage source will be short-circuited, and while the current source should be replaced by an open circuit. So that's that about that. When we are analyzing a circuit now, I would show you how we do that. When we short circuit and when we open circuit. Now, in solving superposition theorem, we also apply current divider rule. So a quick one now, let me illustrate the current divider rule. Actually, this is used to calculate how current divides through resistors in parallel. Now let me say, for instance, now we have a current source now, and then current flows through this source. The current coming from here would go into the resistor 3 and then get to this node or this junction. Now when the current gets here, it's going to split. Some current will go through the resistor 1 and some current will go through the resistor 2. Let's assume the current that goes through resistor 1 is called I1, and that which goes through the resistor 2 is called I2. With this, we can get what the I1 is and what the I2 is, how they share this current. So it simply it means that if the current here is 10 ampere, for instance, how are these two resistors going to share this 10 ampere current? If the current here is 10 ampere from this source is 10 ampere, how will these two resistors R1 and R2 share the current? The R3 takes the whole 10 ampere. So if I ask you now what's current flowing through this R3, the current does not split. It's just that same 10. You can see now the current flows through it. But when it gets to this junction or this node now, that current will break into 2. It will split into 2. Some will flow here, some will flow here. When what will flow here is 4 ampere, and what will flow here is 5 ampere. So how do we get what flows through the R1? Let's say what flows through the R1, we call it I1, current 1. And what flows through this R2, we call it current 2. So current 1 and current 2 is all coming from this 10 ampere. It's just division of this 10 ampere that gives us I1 and I2. Now what's the I1? I1 is simply giving us, to get it, these two resistors are what is sharing the two currents. So it will be R2, this is the formula, over, if you're looking for current flowing through R1, you say R2 over R1 plus R2 times the current they want to share, which is the current coming from the source, which is I source, the current source. If I'm looking for I2, which is current flowing through the second resistor, it will be R1. If you're looking for current flowing here, use R1 over R1 plus R2 times the current they want to share, which is the current source. So this is the current divider rule. Now, another thing I want you to take note is this. If you are asked, I've said that before, what's the current flowing through R3? Very, very easy. It is the current source itself. But current flowing through the R1 and R2, because they are in parallel, you can see that the current splits across them. So these two resistors are in parallel, and that's why we are going to apply current divider rule to know the current each of the resistors takes. So that's that about that. Let's take a quick example on this current divider rule before we proceed to our superposition theorem. We want to determine the current flowing through the 8 ohm and 12 ohm resistor. Now, before we solve this, I want to clearly state that, you see, the current flowing through 10 ohm resistor is 20 ampere. It does not split into anything here. The whole 20 ampere flows through this 10 ohm resistor. The current flowing through this 5 ohm resistor is still the same 20 ampere. It does not split or divide. Please take note of that. But now, when this 20 ampere flows through this 10 ohm and gets to this node or this junction, it will divide. Some will flow through here and some will flow through this. So this 8 ohm and 12 ohm are in parallel. Why? Because current coming is divided, splitted across them. So I want to calculate what is the current flowing through each of them. Well, very simple now. The current flowing through the 8 ohm resistor, current I across 8 ohm resistor, is simply going to be equal to, using our current divider rule, is going to be the other resistor 12 over the two resistors sharing the current, which is 8 plus 12, times the current they are actually sharing, which is 20. And so that's 12 over 20 times 20, and that is 12 ampere. And if I want to calculate the current flowing through the 12 ohm resistor, it's going to be, if I'm calculating current flowing through this, it's going to be the other resistor 8 over 8 plus 12 times 20, and this will still give us 8 ampere. So that's about current divider rule. Now let's take an example under superposition theorem. Now for this question, it says, using superposition theorem, calculate the current flowing through 1 ohm resistor in the circuit below. So I'm looking for current flowing through this 1 ohm resistor. That's our load resistor. In solving this question, solution is simply saying that when you have more than one source, and we can see we have a 5 voltage source, we have a 6 voltage source. So we consider one source at a time. So quite simple now. Let's say, considering the 5 voltage source. So I'm considering this now. I will redraw our circuit. Our circuit will look like this now. For the other source, I will short circuit it. More or less like you remove it. So as though it does not exist. So this is all we have after we short circuit the other source, the 6 voltage source. Now let me assume that the current as a result of this source now, this 5 voltage source now, let's assume that current is called I source 1. The current source 1 as a result of this 5 voltage source. So we want to calculate what would be this current source 1. What would it be? Well, we know that because of this cell here, it will provide a current to this circuit. When that current gets to this node, that current will break into two. Some will go into the 2 ohm resistor and some will go into the 1 ohm resistor. Let's assume what goes into the 2 ohm resistor is called I1. And what goes through the second ohm, which 1 ohm resistor, is called I2. That's it. R3. What goes into it is I2. And what goes through the R2 is I1. We want to get what is the I1 and I2. That's the responses. So first of all, we can say that R2 and R3 are in parallel. We can see that now because if this cell here provides current and that current gets here, it will split. Some will go into it, some will go into this. So these two are in parallel. I can combine that in parallel. I can say that we have 2 ohm in parallel with 1 ohm. Hence, their total resistance of these two, a quick way to do it is just to take, actually it should be, the total resistance 1 over R total is equal to 1 over 2 plus 1 over 1. And then you find all that. But I don't want to take time doing this. I have a quicker method. If you do this to get your RT, you still get the same answer. Actually, your R total should be 2 over 3 ohms. But I have a fast way of doing it. I will just say total resistance of these two will be product over sum. Their product is 2 times 1 and their sum is 2 plus 1, and that will give you 2 over 3 ohms. So this short, quick method of getting total resistance of parallel resistors is just for only 2 resistors actually, so please take note. But that's that about that. Now the next thing we want to do is that I've combined these two, combine and find the total resistance, and that's 2 over 3. I can redraw this to now give me, we have just the 5 voltage source now and the 3 ohm resistor. Then we now have the combined resistance, the total, what I call the R total, which is like the RT, and that is 2 over 3 ohms. This is 3 ohms given in the question. This is the R1. And then this is the 5 voltage source, and this is the current as a result of the 5 voltage source we call I source 1. Now we want to get what is this I source 1. Then this is a series circuit. Now it has become a series circuit. This I source 1 is what flows through this entire circuit. To get this I source 1 now is very simple. When you have a series circuit, the value of your current will simply be the voltage, the total voltage over total resistor there. What's total voltage here? The only voltage here is 5. And then what's the total resistance here? That was 3 plus 2, because these two resistors are in series. Now these 3 ohm and these 2 over 3 ohms are in series. So this will be 3 plus 2 over 3. Eventually, you will have this to be 15 over 11 ampere. So you see, I've gotten the current as a result of this 5 voltage source. The current it supplies this I source 1. The current supplies, the value is actually 15 over 11. Now the next thing is to get what will now be the current this 2 ohm we take, and what the current this 1 ohm we take. Our interest actually is the 1 ohm resistor. So I'm just supposed to calculate just I2, but let's get I1 and I2 using our knowledge of current divider rule. Well, quite an easy one. Simple now. Our I1 will just be, if I'm looking for I1 will be the other resistor, that is 1 over 2 resistors sharing this source. The 2 resistors sharing this source is 2 ohm and 1 ohm. That's 1 plus 2 times the current they actually wanted to share, which is the I source 1. We've got that to be 15 over 11. So I'm applying the current divider rule. I know I needed, that's why I did it firstly, before taking superposition. Now, this will simply give us 3 over 5. That's 5 over 11 ampere. Now, if I want to get I2, what will I2 be? I2 is the current flowing through 1 ohm resistor. I will use the other resistor. That's 2 over 1 plus 2 times the current they are sharing, 15 over 11. And that will give us 10 over 11 ampere. So that is the I1 and I2 as a result of this 5 voltage source. So having done, since we are done with this 5 voltage source now, we need to look at what is the current as a result of the 6 voltage source, because we have 2 sources here, 5 voltage source and the 6 voltage source. So let's consider the response as a result of the 6 voltage source. So considering now the next one, the 6 voltage source, we would have, I will close circuit this 5 voltage source. So we left with just the resistor there, and then since we are considering the 6 voltage source, it will not be there now with the 2 ohms in that part, and then lastly the 1 ohm resistor. So the 1 ohm resistor, the 2 ohm resistor, and the 3 ohm resistor, R1, R2, R3, and this is the 6 voltage source. Now this 6 voltage source will give us, supply a current. Let's call that the I source 2. Now this current source now, by the time it gets to this junction, the current flows and get to this junction, it is split into 2. It will divide. Some will go in here. Let's say what goes in here is I3, and what goes in here is I4. I'm not going to say I1 and I2, since when we consider 5 voltage source, we call those current that divides I1 and I2. So let's not confuse ourselves with same representation. So we use I3 and I4. Now that clearly tells me that 3 ohm is in parallel with 1 ohm resistor. I'm going to combine that together. So it will be 3 ohms in parallel with 1 ohm. If you combine this, the total resistance will be 3 times 1 over 3 plus 1. And that will give us 3 over 4 ohm. That's the resistance, total resistance. Now, having done this now, I've combined these two to be 1. I will have it like this now. So these two combined are combined here to give us 3 over 4 ohms. So this is the RT. This is our 6 voltage source. And this is the current as a result of the 6 voltage source, I source 2. And then this is the 2 ohms in this place. So I've combined this 1 and 3 ohm together. Now this becomes another series circuit now. So I want to calculate what will be my I source 2. Again, my I source 2 will simply be the total voltage V over total resistance. The only voltage here is 6. All over, what is the resistance? Total resistance. That will be this and this. 3 over 4 plus 2. Okay? So, if we carefully do this, we get our current to be 24 over 11 ampere. So the next thing we want to do now is to get, if the source now is 24 over 11, then how do we want to get what the I3 and I4 is? Well, our interest should be I4. I'm supposed to do I4 alone because they say current flowing through 1 ohm resistor. But still, let's do for I3 and I4. So let's take I3 first. I3 will be what? So inside this 24 over 11 ampere, how many of that 24 over 11 flows through the 3 ohm resistor? How many of it flows through the 1 ohm resistor? Since they are in parallel, I'm going to apply the current divider rule. And that will simply be, if I'm looking for I3, that will be the other resistor, 1 over the 2 resistors sharing the current. That is 1 and 3. 1 plus 3 times the current they are sharing, which is 24 over 11. So if we do this, we are going to get 6 over 11 ampere. Now, what is I4? I4 quickly will be, I4 means current flowing through the 1 ohm resistor. So I'll use the other resistor, 3 over 1 plus 3 times the current they are sharing, 24 over 11. And that will give us 18 over 11 ampere. So that's that about that. Now, having gotten this now, we want to now get the total response. So I'm going to be rejoining this circuit now and writing out the answers we got previously. Now, this is what we got when we consider the 5 voltage source, and this is what we got when we consider the 6 voltage source. Now, the point is, we want to calculate the current flowing through the 1 ohm resistor. That's what the question said. So, current flowing through the 1 ohm resistor. Now, when we consider the 5 voltage source, the current flowing through the 1 ohm resistor is just I2. And that I2 was 10 over 11. Plus, when we consider the 6 voltage source, current flowing through the 1 ohm resistor is I4. And what's the value of the I4 now? 18 over 11. So this is what the superposition theorem is simply saying. Now, total response is algebraic sum of the two responses, of the individual responses, sorry. So if you sum this up, we get 28 over 11 ampere. We not just add, actually. You can also be subtracting. But the reason why I added this is because if you consider this 5 voltage source, the current flowing through this through this 1 ohm resistor is flowing downward like this. And when you consider the 6 voltage source, the current flowing through this I4 is also will also flow down. So the two are in the same direction, and that's why we sum that up. If I was to calculate current flowing through, for instance, the 3 ohm resistor. We're not asked this. I'm done with the question actually, but I want to illustrate something here. If I have to get current flowing through the 3 ohm resistor, which is this guy now, I will say for the first one, what was the value? That's the I source 1. I source 1 is what flows through this 3 ohm resistor. And what will be the value? 15/11 ampere. Now, what's the current flowing through the 6 as a result of the 6 voltage source? It is I3. And that I3 is gotten to be 6/11. But if we look carefully now, why I source 1 flows upward through this 3 ohm resistor, I3, because of the 6 voltage source, flows downward. They are in opposite sense. I need to subtract. And how do we do the subtraction? The bigger one minus the smaller one actually. The I source 1 is bigger than the I3. Because I3 is 6/11 and I source 1 is 15/11. I source 1 and I3 are what flow through this part. In the first one is I source 1. In the second one is I3. So I'm going to subtract them now. So for this one it will be, like I said, I source 1 minus I3. Why? But that's the two current that flows through this 3 ohm resistor. And they're in opposite sense. That's why they're subtracting. So in this case now it's going to be 15/11 minus the I3, which is 6/11. And that will give us 9/11 ampere. And that current, how will it flow? It will flow in the direction of the bigger one. So the current actually flowing in this one is actually going up, and 15/11. If you use any other theorem to solve this question, you will still get the same answer. So if I'm calculating current flowing to this 2 ohm resistor, what will it be? You can try that on your own actually. You can pause the video and try. But if you try this and solve accurately, you will have it to be I source 2 minus I1. And I source 2 is 24/11 minus I1, which is 5/11. So this will give us 19/11 ampere. So that's that about that for this question. Let's take another question. Okay, so using superposition theorem, calculate the value of I in the circuit below. So let's solve this now. Solution. The first one is to consider the 10 voltage source. That will mean removing all other sources. The 15 voltage source is removed and short circuited. And then the current source is open circuited. We open that part. So this is what we have now. Well, because this part is open, no current flows. Current can only flow through a closed part. So we just have a series circuit like this now. Just a series circuit. And the current we get from this cell here, let's call it I source 1. We can say, since the series circuit, we would have it to be that the I source 1 is simply going to be V over the total resistance in that circuit. And that will simply be 10 all over. The total resistance here is 2 plus 3 and plus 5. And this will give us 1 ampere. The next one now is to consider the 15 voltage source. Considering the 15 voltage source, that will be removing the 10 voltage source now, and then the 3 ohm, the 15 voltage source, and then the 5 ohm with the 10 ohms with current source still open circuited. So this 2 ohms, and then this 3 ohms, and then this 5 ohms, 15 volts. Well, again, this is a series circuit. So the current from this cell, let's call it I source 2. Then we can say that I source 2, which is the voltage, since it's a series circuit, over total resistance in the circuit. Current will not get to this 10 ohm resistor since this part is opened. So that will be 15 over total resistance here. 2 plus 3 and plus 5. and that will give us 1.5 ampere. Then lastly now, considering the 5 ampere source. Okay, and that will be, we remove all other sources. Okay, so this is 10 ohm, 5 ohms, 3 ohms, 2 ohms. So we want to see if 5 ampere gets here and then split. 5 ohm in parallel with 3 and 2 ohms. So we want to calculate what is the current now that gets to this part here and here. Let's call this I1 and let's call this I2. Actually, we need our I1. And so I1 using current divider rule is going to be 5 all over 2 plus 3 plus 5 times the current they wish to share times 5. So this will be 2.5 ampere. So we're almost done now. Remember that in the question, we are asked to get, let me assume this is the circuit of the question now. We have to get I here in the question. I've cleaned the diagram of the question. We have to get I here. How do we not get the I? I've calculated all the currents from all of the sources now. So let's get this I now. How will it be if the I was here? I'm assuming that this is the, let me make this the complete question of this. Complete of the part of the complete question. It was like this. That the question is, and we have to get this I. Now, in the first case, what flowed there was I source 1 when we consider 10 voltage source, and the value of I source 1 was 1 ampere. In the second case, what flowed here, flow in this direction, was I source 2. Because I source 2 will flow like this, because this is just a series, a single mesh circuit. This no current flows there, so we'll consider only this one. So what flowed there was I source 2, and the value was 1.5 ampere. And in this case, consider this one, what flowed in this part also. So I'm considering only what flowed in this part alone, since that's where the I in the question, which we are asked to get, lies. So next I'm going to do is that this I will be equal to, now it's equal to I source 1. Yes, why? Because I source 1 flows in the same direction as this I. Then it is minus I source 2. Why? Because I source 2 when flowing here flows in opposite direction. This I goes like this. Why this I source 2 goes like this? Opposite. That why it's negative. Next one is this I1. This I1 flows in opposite direction to it also. So this is going to be minus I1. So this will be I source 1, which is 1, minus 1.5 ampere. Again, then minus 2.5. And that will give us minus 3 ampere. That's the answer to this question. So we can try this exercise on our own. The question is, using superposition theorem, calculate the current and voltage drop and the power dissipated in the 8 ohm resistor. So for this, the answers are actually here. So that's about superposition.